Hello everyone, I'm Paul and today we're solving problem 75, sort colors. This is a medium problem and there are at least two efficient ways to solve this one, so here we will go over both. We're given an array nums and we need to sort the array in place. Now the main observation here is that the array can only have zeros, ones and twos, and each number represents a color, red, white and blue. And here we have a restriction, and is that we can't use the sort function. So let's see an example. Let's say we have this array. For the first strategy we can build a frequency map. So here we have 2 zeros, 2 ones and 2 twos. And now once we have this, we can iterate this from left to right, and first we can replace each element with a 0 until we run out of zeros in the frequency map, and then do the same with the ones, and then do the same with the twos. So for example, the I pointer is here. We have 2 zeros in the frequency map, so we can replace this with a 0 and we move the I pointer. Now I is here and we have 1 0 remaining in our frequency map, so we can use a 0 here and we update I. Now we don't have any zeros, so we check if we have ones available. We have 2, so we replace this with a 1. Now we have 1 remaining and we update I. Now we are here and we have 1, so we use the one we have here, and now we have 0 ones. Now I is here, we don't have any more ones, so we use a 2 here. Now we have 1, 2 available and we update I. Finally we have 1, 2 here, so this is now a 0 and we replace this with a 2. Next we update I, we reach the end, and this is the final array. Time complexity for this will be big O of n, because we are iterating this array, and space complexity will be big O of 1 because of these variables. So now let's go with the code, and remember, then we are going with this second solution. Here we don't have to return anything, we just need to modify nums in place. So n equals length of nums, zeros, ones and twos are initially 0, 0 and 0. And now for every value in nums, if x equals 0, zeros plus equal 1, else if x equals 1, ones plus equal 1, else choose plus equal 1. Now for I in range n, if we have zeros, zeros minus equal 1 and nums at I equals 0, else if we have ones, ones minus equal 1 and nums at I equals 1, else this means we have choose, so choose minus equal 1 and nums at I equals 2. So this is the entire code, and now let's submit this. And as you can see, this works. So now let's go with the second solution. For the second solution we have 3 pointers, low, mid and high. And remember, we only need to sort 3 possible colors, 0, 1 and 2. And if we find a 0, for example, we will swap this 0 by whatever we have in the low pointer, and if we have a 2, we will swap this 2 by whatever we have in the high pointer. So we're moving these zeros to the front and we are moving the choose to the end. And if we find a 1, we just continue. This is the whole strategy, and now let's see how this works. We are always looking at nums at mid, so in this case we have a 2 here. And remember, when we have a 2, we want to swap this with whatever we have in the end, in the high pointer. In this case we have a 0. So this is now 0, this is now 2, and whenever we swap with the high pointer, we want to update high one step to the left. So the high pointer is now here. Now we are checking nums at mid again, and we have a 0. And whenever we have a 0, we swap the mid element with the low element, and we update both low and mid one step to the right. So this is still 0, and low and mid are now here. Now we are looking at another 0, so we update low and mid once again. Now nums at mid is a 2, so we need to swap this 2 with whatever we have in the high pointer, in this case a 1. So this is now a 1, this is now a 2, and we update high one step to the left. Now nums at mid is a 1, and whenever we have a 1, we just update mid. Now mid and high are at the same index, and nums at mid is 1, so we update mid once again. Now the mid pointer is greater than the high pointer, so we end the loop, and this is the final array. Time complexity for this will be big O of n, and space complexity will be big O of 1. So now let's go with the code, and hopefully you will get the idea. First, n equals length of nums, low is 0, mid is 0, and high is n minus 1. And now while mid is smaller or equal to high, if nums at mid is a 0, we need to move this to the front, so we will swap nums at low with nums at mid. And in case you didn't know, you can swap elements like this in Python. This equals nums at mid, nums at low. And now we update the low pointer one step to the right, and we update the mid pointer one step to the right. Else, if nums at mid is a 1, we just update the mid pointer one step to the right. Else, meaning if nums at mid is a 2, we swap nums at mid with nums at high. So this is nums at high, nums at mid. And we update the high pointer one step to the left. So this is the entire code, and now let's submit this and see if it works. And as you can see, this works, and it's also very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.